is when we have a binomial times a binomial. So for all those of you playing at home, today is the 7th of December, and we're working on 11.3.
Is anyone not here?
No, but in the future, I might use these videos again for other things.
If he's sick.
Yeah, or if I decide to blend a chapter or a specific day or something. So it may no longer be the 16th, and this lets me know, though, what pacing we took this year. So this year, December 7th, we're in chapter 11. Last year, all I have is like a plan book that I can go back and look at and see where were we last year. Next year, I'll be able to go back and look at YouTube. Where was I on 12.7? Lets me know if I'm moving faster, slower, different, whatever. So when we talk about the FOIL process, up here on the TV you can see it's really just first, outer, inner, last. It works really nice with binomials, and your outer and your inner are going to end up being like terms as long as the binomials are both in the same form, which is exactly what we have in problem 1 here. So we want to work through this, and let's just be real formal to start. Let's go ahead and write out an F, O, I, and L. What are my first terms that are going to multiply together? Michelle? The 2x and the 3x. And that will give us 6x squared. My outer terms, so now I look at the whole thing together. 2x is on the outside, and negative 7. That'll give us negative 14x. My inner has a 4 and a 3x. So we get 12x. And my last have a 4 and a negative 7. So we get negative 28. Now we're going to put these all together and clean them up. I have like terms from my outer and my inner, so go ahead and think about what would negative 14x and a positive 12x give us. So in standard form, we always write this from highest power down. So 6x squared minus 2x, or you could say plus negative 2x, but that would be kind of extra work we don't need to do. And then minus 28. This is my simplified. And now, what would we call this? How many terms?
That's a trinomial.
Trinomial. What's the power? Quadratic, right? Because it's squared, we know it's going to be parabolic. This would be, if you care, a quadratic trinomial.
Fancy word.
So try foiling the got it on your own. You do not have to write out like the FOIL. You can just kind of draw arrows if you'd like. Whatever method is easiest for you. So when I start processing through this, Emma, what'd you get for your first terms multiplied together? 4x squared, because we have an x times the 4x. When we go to my outers, Calvin, what'd you get there?
3x.
Yeah, just 3x, because it's a 3 times the x. Carmen, what'd you get for your inners?
Negative 24x.
Negative 24x. 4 looks weird. And my last value's normally going to be a constant. Straubler?
Negative 18.
Negative 18. When I put this all together, Scarlett, what's that come out to be cleaned up?
Oh, I did something wrong, but 1 second. 4x squared plus 21x. Wait.
Close.
No. I know what
Minus.
Okay. Minus, yeah.
Because the negative is more powerful, when I combine it together, I get a negative 21x or a minus. And then,
Minus 18.
yep. Any questions on what we're doing? Preguntas going once, twice. So now we're going to do this through the array method, which we also just call using a table. But now with the new math standards, we've called it the array method because we have one of our polynomials going in array one direction and one going the other direction. Then we use the table to solve out. We're essentially foiling here. So if I look at the products of x and 4x, what do I get?
4x squared.
4x squared. When I look at negative 5 and x,
Negative 5x.
negative 5x. 4x and negative 3, negative 12x, and a negative 5 and a negative 3, positive 15. So when we go to clean this up, we get 4x squared minus 17x and a positive 15. Same exact thing we'd get from a FOIL. Now, where would the array method potentially be more useful or simpler, I guess, than the FOIL method?
Trinomial.
Ooh, when we start using try or like fourth or fifth or so, like any polynomial bigger than a binomial, that array method is going to be nice and easy. Now we could still use a modified FOIL method. There's just a lot to keep track of. The table is really nice for keeping order, and if you want, I just had to cut it out of my copy, fill in those lines so that it looks a little nicer if you want. I'm going to recapture it with those. I realize it's not divided very well. So, real quickly, just to practice how we can like efficiently set up a table, you don't need to be real formal. Just make like a modified t-chart, leave your top left blank, then put your terms 3x and 1 across the top, split that, and then x and 4 across the left and split that.
Wait, does it matter where we put them?
No, as long as you have all 4 terms up here, it doesn't matter the location.
Okay.
Because each term is going to multiply by the other, well, okay, so let me take that back. Your 3x and your 1 have to be on the same part of the table.
Yeah,
So you
that's
can't break those up.
Yeah. I know.
Yeah, but I could switch these around
Okay.
because addition's commutative. The
Okay.
order in which they're added doesn't make a difference.
Okay.
So now x times 3x, we get 3x squared. Ethan, you can probably walk me through the rest of this, right?
Yeah.
What do you get?
X.
X.
12x. 4.
And when you clean it all up and combine,
3x squared plus 13x plus 4.
any questions? So, can we, because we had introduced FOIL earlier, can we go ahead and skip the problem 3 part where it just formalizes how we do FOIL? The difference of how we would have done problem 1 if we didn't know how to FOIL would have been that we would have had to long distribute each of them. So here, don't write anything down. I want to show you why we're skipping part 3. Problem 1, how it wanted us to do it, would have said 2x times the 3x and 2x times the negative 7. Then 4 times the 3x and 4 times the negative 7. But we already discussed this previously, right? So we're cool?
Yeah.
Okay.
Pretty much what we did, right?
That's basically
Well,
FOIL.
yes, but we jumped straight to FOIL as opposed. So yes, it's exactly what we did.
Oh, so
It just
there
looks
one
different.
We used distributive, but
isn't it
down
do, like,
there
the
one
exact
we
same
used
thing?
FOIL?
The distributive process is first, outer, inner, last. If you care, that's the only difference. I'm not joking.
Does that
Wait,
change anything?
FOIL is
No.
first outer
Yeah,
inner last.
Or-
FOIL is first, outer, inner, last. I mean, first, inner, outer, last?
Yeah.
Firsts,
No.
outers. No, that is. Like, well, depending on what order you do it, but if you distribute from your first term and do to there and then to there,
Outer,
you get first outer. Then, if I move on to my negative 4 times the x, that's my inner, and my lasts, it really is FOIL, which I thought it was a different order, but it really changes nothing.
It's just a way of remembering it.
And really, though, I don't like that we gave it that like nickname, because then all people remember is the nickname, and it's not like the process of what if I have a binomial and a trinomial.
Everything times everything.
Yeah, it's just everything times everything. Make sure each of these terms hits each of these terms, and vice versa. What? That's the technical way to say it. So write the polynomial that describes, what are we trying to find? The surface area of our cylinder. So we know our formula that our surface area is 2 times the base plus the lateral area.
Yeah.
Let's deal with our base first, just because it seems like it should be a little bit easier, hopefully. How do I find the area of my base? Mr. Walker?
The area of the base is the pi r squared, and the radius is x plus 1, so you have to square that and multiply by pi.
So we are going to do pi times the radius, which is x plus 1, squared. So this brings up the idea of what happens when I square a binomial. Well, when you square something, it's times itself, so we're still going to have a binomial times a binomial. But is there an efficient way to deal with squaring this so I don't have to think out the whole process? And every year, just to avoid this, somebody says, oh, just square that and square that.
No.
But we discussed this a couple weeks ago where, no, that doesn't work. What's the efficient way that I can think about the squaring process? Carmen?
Squaring is really something times itself. So you do like x plus 1 multiplied by x plus 1. But
I
then you have to
agree.
do the FOIL.
But then if I have to do the FOIL, that's not any more efficient. I agree with your process. I'm just trying to find a really efficient way. So if you think through what happens, and don't write it down here, but if I think through what happens when I do the FOIL, well, really, like you just said, it's x plus 1 times x plus 1. But then again, that makes me do the whole process, and that's a little long. But let's look at what happens. My firsts would give me x squared. My outers would be 1x. My inners would be 1x. So I'd really get 2x. And then my lasts, 1 times 1, is 1. What if I change it to a different binomial? Hang on to it for a second. What if it was 3x plus 4? Let's use some different examples. If you have a little bit of space somewhere on your paper, throw 3x plus 4 squared down somewhere.
Like,
If
in
not,
the 3 got it. Like up in the 3 got it.
oh yeah, sure, that'd work.
It's almost like you planned.
So then my firsts, 3x times 3x, would be 9x. My outers, yes, thank you. My outers, 3 and the 4, or 3x and the 4. Then my inners are 3x and the 4. So I get 12x twice. And then my lasts are just my 4 squared, or my 16. So here's the trick.
Wait.
Can you give it to me algebraically?
Like in a formula.
Yeah, like if we have a plus b squared, what it turns into.
A squared plus 2ab plus b squared.
This is the quick way to avoid foiling. Because when we square it, no matter what my a and b values are, I'll square my first term. When you start using it, yeah, I hear the murmur of like, is that really easier? All I got to do is square my first term, square my second term, multiply the 2 terms together, and double it. And that gets me right there. So up here, again, if you don't like it, use the other method. I'm just teaching you multiple ways. Up here, and we have x plus 1 squared. I can square this, square that, multiply, and double. So this becomes pi times x squared plus 2x plus 1. Boom. Nothing to think through.
That simplifies to pi x squared plus 2 pi x plus pi.
Right. So then this is really, does it say terms of pi? No. We're going to leave it in terms of pi. Sorry, my board is disaligned over here. It's making it awkward. And two of those, if I bring it back over here and plug it in. So then my lateral area. So we gotta look at lateral area. Well, how do we really calculate lateral area? Don't give me the formula, but what we just really need to do. In a cylinder, my lateral area, or like the space around the pop can or whatever, is really like a rectangle. So to get that rectangle, what do we multiply together? Is that a hand or is that a like an sure?
Wouldn't it be the base times the height?
What is the base?
Whatever that is.
Whatever. What is that?
Pi x.
Now we're talking about lateral area. You're thinking of volume. If you use the base area, then you're talking about volume. Shell?
The perimeter of the circle.
What's the perimeter of a circle?
Two times the diameter times pi.
Ooh.
Or
Either diameter pi or 2 times radius times pi. Don't use 2 and diameter at the same time.
Oh, I was gonna say 2 radius and then I switched
Yeah,
to
you
diameter,
switched.
but
It's okay. So, lateral area is really my circumference times my height or my distance between the bases. So my circumference is 2 times pi times that radius, x plus 1, times the height of x plus 4. So now I have a binomial times a binomial again. Solve on your paper what x plus 1 times x plus 4 would give you. Then simplify it with the 2 pi. Try not to look up here if you can avoid it. If you have it, or if you want to verify it. Give a look up here. Yay, there was much rejoicing. Now we need to combine.
Plus 10 pi.
Ooh, forgot my x. Thank you, Caleb. Don't forget to bring every piece. Megan?
For where you wrote back down the base, isn't there an x after that too?
Yep. I'm showing you mistakes so that you don't make the same mistakes.
That's
Like,
Definitely.
see, other teachers tell you that, like, you don't know. I know you guys know. I made a mistake. It's okay. Happens. So I'm going to go ahead and think about this after I would have distributed the 2 and added the like terms. So this would have been 2 pi x squared and another 2 pi x squared. So really, 4 pi x squared. Then I've got my 10 pi x plus how many pi x would I have had from the bases? So together we get 14 pi x. And then I had a 2 pi and an 8 pi and a 10 pi.
pi x sounds really cool. It
Mm.
sounds like some game.
Would that be like pix? Pi x? I don't know. You could start a business. Call it pi x and confuse people.
What would the business do?
I don't know. Maybe you could take pictures.
Sell
Still pi. Pi.
Just the
pi
choose a
x.
pi.
Or it could be nothing to do with anything. Like, you know what I mean?
And there's a bullseye.
Try this on your own. I'll give you a couple minutes to solve it out. You may work with your partner groups. Please stick up a hand if you are having any issues. Yeah.
We can do it in terms of pi, right?
Oh yeah, leave it in terms of pi. You're missing a lot of labelings here.
So this is 2b. For our base, I got
Hold
pi
up.
x squared plus pi.
So where did your middle, your outer and your inner term? So you're not showing the work for what we set up to do pi times radius squared. Because this is incorrect for your 2b. So to get our big B, so notice all this up here in blue, that you don't have any of that written down.
Yeah.
That's what you're missing. That's where your issue is. Because when we go to do pi times the radius squared and we square x plus 1, that is not x squared plus 1. That squared comes out to be x squared plus 2x plus 1. You're missing that middle term because you didn't follow the process. I need a pen. Oh, I have a pen. So here's your issue. When you go to do that, the area of a circle is pi times radius squared. That turns into pi times x plus 1 squared. If I wrote that out, it'd be x plus 1 times x plus 1. When you square something, it times itself. Then to multiply these, this x has to multiply by that x and that 1. That 1 has to multiply by that x and that 1. When I multiply that out, whether I FOIL it or whatever method I use for multiplying them, I could use the square method that we talked about. I think it's the next slide back, but where like we can square, square, and then multiply these together and double it. Or if I FOIL, firsts give me x squared, outers give me 1x, inners give me 1x, so those together give me 2x, and then these give me 1. Regardless, I get x squared plus 2x plus 1, and then the pi has to distribute to all of those. This right here is what you're missing over here, because this would give me pi x squared, and this would give me pi, and then we double it, because this is just one big B, so you have everything but that middle term. Okay, try to process through this one and see if you get the same results.
How long is our homework?
Like full budget.
We're gonna do another. It's only 35 questions. We're gonna do evens or odds again.
Oh, okay, wonderful.
Because like all of this section is the array method, but it's
Okay.
really once you've done some like the practice that we do is so that you get fluid, so it's fast. Because I do not want you to look at a test and be like, this again, crap. I want you to look and be like, oh, I've done so much of this.
Oh.
It's like fine.
We are supposed to do that?
Same.
So, Lynn, when I look at this situation up here, what's the radius that I'm going to use for my cylinder?
No. Well, the radius is x plus 2.
Yeah, so when I come up to my circle formula, like area of a circle, I have pi times that radius of x plus 2 squared. Now, when you go to square a binomial, what method do you want to use? Because there's like a bunch. We could use FOIL, we could use array, we could use our shortcut, and use FOIL. So, if I think about foiling, somewhere else, which is why I like to have a pack of Post-its, I would either think through or write out x plus 2 times x plus 2, and then process through the first, the outer, the inner, and the last. My firsts, so Lynn, what do I get when I do my firsts, x times x? Ooh, close. x squared. Then my outers here, x times 2. That's our 2x. Then my inners are 2 times x. Also 2x. And then 2 times 2. Boom. We clean it up, add those like terms together. And then I can bring it back up here. Ethan, are you with me now on that middle part that you had been missing? I'll come back to that to double it for 2 times the big B. But Max, when I start looking at the lateral area, what do I need to do there?
2 pi times x plus 2 times x plus 4.
So yeah, it's 2 pi times radius times the height. So you did 2 pi times the x plus 2 times the x plus 4. What'd you get when you foiled these together?
X squared plus 6x plus 8.
Here's the other trick with foiling. Same, well, similar to like when we square things, and you should see this as we do more and more of these. I just multiply, add. Now, if your first values are the same variable, all I have to do is add these together and put it on the variable for your outer and your inner. When the first one is different, like this might be x and this might be x squared, then that changes everything. But while we're working with easy ones, you should start to kind of see the pattern that we get here. Then product down to there. And when we put it all together, 2 pi x squared plus 12 pi x, not going to forget my x there this time, and 16 pi. Any questions?
Final answer?
No. Any questions how we've gotten to this point?
Yes, many.
How? What?
I had no point in doing any of this that I ever get a 6. Which is why I'm very confused.
16.
It's a 16.
Where's the 1? Not that. No, I'm talking about you said 2 pi times the x squared plus 6x. Where'd you get the
Because when you
6x?
First-
FOIL x plus 2 times x plus 4, then you
No.
get x squared plus 6x, because
This is like the most important part right here is finding our mistakes. Where did we screw up?
Everywhere, apparently. Because at no point in the lateral area.
So where does your process break from ours?
He might have gotten there a different way. I got there a different way. I didn't see that, but
Okay, let's see the final answer.
Okay.
Right?
Okay.
Show the final answer.
So before I go there, because I want to erase some stuff, are you with me on the base area being pi x squared, 4 pi x, and 4 pi for one of the base area? Okay,
I
so
got
I'm
that, and
going
then
to erase this.
Wait, can I tell you what I got for the lateral area?
Yeah.
Okay, because I think this might be where I think I went wrong in the lateral area. I got 2 times pi x squared plus 5 pi x plus 4 pi.
So your, I think the values that you had in here are off.
Maybe.
Because, so, to find our lateral area, in general,
Wait a minute. I might know.
Calvin,
okay, what do you think,
What
man?
did you get for your last value?
my very last, like, final value,
No, like the one that didn't have an X. It was 4
one that
pi.
didn't have an x, 4 pi.
You used the picture cylinder.
Oh.
And you added the one before, which you shouldn't have done anyways.
Wait.
Caleb.
So you got to keep it straight which values we're using.
No, you won't. Oh, no, never mind.
Are we good now?
Wait, then how'd I get the... Now I'm confused on how I got the base right, but I got the lateral area right.
Because then you switched which values you were using. If you let me see your work, I guarantee I can find it.
Oh, there we go. There's that one. Silly me.
Okay.
Silly
Now,
me. Thanks, Calvin.
Calvino, the linguine 5.
now, again, think about combined. Now, I really
It's 'cause
should
you're
have this written out somewhere. This is pi x squared
I bamboozled myself.
plus 4 pi x plus 4 pi. All my things look really nice. So now my total surface area, combine all your like terms. I have a 2 pi x squared and a pi x squared.
Hey, wait a minute. All one base.
Calvin.
That one was actually on purpose. I was waiting. I was hoping it wouldn't be you. You gotta let
I
like
just
other.
did the same thing.
Sorry, I'm not really paying attention.
So this is why I wrote it out over here. You gotta remember this is only one of your bases.
He fin riddled.
So if you're gonna leave it like that, double it mentally. 2 pi x squared, 2 pi x squared,
4 pi
Wait, could I just add?
4 pi x squared, or add it twice.
Okay, thank you.
Like
I'll bamboozle
12 pi x plus
4 pi x.
8 pi x if you want to do your
I'm
2b.
good so far, Mr. Hudson.
And then 16 pi and
I
8 pi.
Darn it.
I still figured
I
it out.
didn't.
Oh yeah.
I feel a little
I didn't.
cheesed off of myself that I just used the wrong value.
But do you know what mistake you made?
Now I get why I got a completely different.
Then this is worthwhile.
the first
You don't need to erase or anything as long as you know what
At
you
least I got
did.
the base right, which
Yeah.
says I know how to do it.
Darn it.
Any other
And
questions?
you got
So
the lateral
close.
area correct for the values you were using, so you know how to do it.
Yeah, it's not like did you get the right answer, it's did you follow the process correctly.
Yeah, I just used the
Now,
wrong
when you
value.
actually have to show that you know how to do it, then you need the right answer. But as long as, like, if you swapped a value accidentally, okay. Like, it will be easier on the homework when it's this image than that image, and they're very, very clear.
Okay, no way.
I'm not worried about you.
Everybody must have-
So, here is one of those methods where I would not do what it's asking me to do. Now, you can if you want to. This is like your standard old-fashioned long multiplication, just like long division, where I take each value from the bottom and multiply it by each value in the top and then work vertically down. A better way to do this, in my mind, is array method. So, in order to have some space, let's just skip that. We can come back to it if we want. Let's go down to the guide. Let's set this up using array method. So, if we instead just put my 2x squared, my negative 3x, and my positive 1, and then an x, and a negative 3. Let's work with the x all the way across. So, Megan, my top line as I go across, x times 2x squared,
2x cubed.
2x cubed, x times negative 3x,
Wait. Okay, sorry, I did this different. Negative 3x squared.
and my last,
1x.
just x. And working across the bottom, Mr. Straveler,
What?
my bottom row here, negative
Oh,
3
I
times everything.
I got this. Negative 6x squared. 9x. Negative 3.
Now, manually, well, I guess there's no real alternative to manually, but find your like terms, and as you pull them out of the table, just combine them. 2x cubed has nothing like it, so 2x cubed. Then, my negative 3x squared and my negative 6x squared, they're both negative. They make a bigger negative. We get
Minus 9x.
And
minus
2x
9x squared.
What's that? Because,
What?
you know,
I forgot a 2x squared.
Where?
Oh, never mind. Just kidding.
That's
Forget it.
cubed.
Never mind.
Yeah, it is
Twos and
not
very
like.
Yeah.
Hmm?
2s and 3s are very
They do.
Yeah, I've
Yeah, I've
written so many twos and trigonometry.
Then 9x and x, we get 10x, and then a minus 3 to finish us out. Any questions? Caleb?
Do you know how many of the like ones where you have to find the area, like lateral area, of on the like, are on the homework?
Oh, not a bunch. Like those are very big. So those sort of problems are where if you were like an engineer and you were trying to decide, and there's a lot of great jobs in engineering, like pay you well jobs in engineering. Huh?
It wouldn't be like a thing that you could just plug numbers into.
Yeah.
Yeah, but you'd have to
Write the
write the code in the software before it would do what you want it to do. So you can't just like download a software that's set up for the problem that you're looking at. You would have to take the problem that you're looking at, write the code, like you'd have a software already, but you'd have to tell it what code to use.
Yeah.
So then you'd write the code to say, okay, I have like a can or whatever that is going to be some variable plus 1 or however much extra, and then some variable plus however much extra because they want a certain ratio. And then you could say small can, big can, jumbo can, like you could plug in all sorts of independent variables. But then you've got your surface area or your volume or whatever calculated to plug in the variable and you're done. As opposed to plug it in, find your dimensions, and recalculate. So even your TI-83 can do this for you if you write the, well, once you have one, you'll probably get one in high school. If you like plug in a formula for a surface area of a sphere, it'll do it for you when you tell it the radius. But you have to teach it the formula. So just like that with all the computer programs and everything out there, you just have to know what to plug in. You got to be smart enough to do that. Then it will do the work for you. But I do agree with you. There's a lot of technology applications where like your guys' life will be easier. Like you will have less to do as long as you know a certain amount. All right, guys, that's all I got for you today. Evens or odds on that, whichever you choose. You may do the whole thing if you'd like, but I know it's a lot, so do it until you are comfortable.
This is actually pretty easy.
I like hearing that, but easy is relative.
This area